Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, today's topic is from a listener, and I can't say their name. And I think it will become evident as to why when I read this email.
Because they're in the Witness Protection Program.
Nope.
Oh.
I don't think they'd tell me if they were, hopefully.
Yeah, that's true. That'd be a good thing to not tell the podcast that you're writing into.
So here it goes. This holiday season, I'm looking to get a nice piece of antique silver jewelry for my girlfriend. I see nice pieces for her, but they look a little tarnished. First off, what is tarnish? And second, how can chemistry be used to remove it?
Oh, nice.
So I'm trying to maintain the element of surprise for this person just in case the girlfriend listens and maybe she doesn't know what she's getting. I don't want to call them out, you know?
Totally. Well, thank you, mysterious listener, for that question. That's cool. And also, I'm glad that you thought about that, about not saying his name.
Yeah, so you know who you are, mysterious listener, and hopefully you're not sad that we didn't say your name, and hopefully this mystery and surprise element is preserved. Okay, so silver tarnish is just a chemical reaction.
Nice. All right.
So that's it.
You got your answer, dude.
Do. No, I'm just kidding. Okay, so what happens is silver reacts with something in the air to make something new, and that new thing is present on the surface of your silver.
Oh, okay. That actually is huge, though, because it's not like it's the silver thing itself that's changing. It's a new thing.
It's a new thing.
Got it. Okay.
So chemistry is all about electrons.
Mm-hmm.
We've talked about that before. Electrons will be gained or lost to make cations or anions. Electrons that are shared between two atoms is known as a covalent bond. If you have a positively charged and a negatively charged atom, one that's lost and one that's gained electrons, they'll be attracted to each other, and that's called an ionic bond.
Mm-hmm.
A lot of reactions are basically just the movement of electrons.
Right. Okay.
That's what drives them. That's sort of the, I would say chemistry in a lot of ways is driven by electrons and energy.
Okay.
So we've talked about that before. In the Rust episode, we talked about the oxidation and reduction, how oxidation is losing electrons and reduction is gaining electrons. And that's a little counterintuitive because reduction is gaining. That doesn't make sense, but it's about the charge because electrons are negatively charged. So if you gain some, your charge overall is reduced. If you lose some, your charge overall is increased.
Right.
So what's happening to silver when it tarnishes is that this silver metal itself with electrons is losing some of those electrons.
Okay. So
And
oxidizing.
That's right.
Okay.
It's oxidizing. It's being transferred to other things, the process of oxidation. But in this case, it's not necessarily being transferred to oxygen.
Okay.
It's being transferred to sulfur.
Oh.
So the oxidizing agent is normally oxygen. It's oxygen and rest. But in this case, it's sulfur in the air.
So I was going to say, there's just sulfur in the air?
There's just sulfur in the air. And sulfur is in the air as a result of some industrial processes. There's sulfur compounds in eggs, in mayonnaise, in rubber bands, in mustard, and stuff like that. Just around your house. There's some sulfur that can just be sold, elemental sulfur, as antifungal fertilizer, I guess. It's just straight sulfur to put on your plants.
Oh, weird. Huh.
To keep it from getting fungus. So there's just sulfur around. And sometimes it's in the form of hydrogen sulfide gas, and sometimes it's in the form of other sulfur-containing compounds, but sulfur's around.
Interesting. Weird.
So your silver metal can react with very low amounts of hydrogen sulfide or sulfur compounds in the air, or if you stick your hand with a silver ring or something on it into a jar of mayonnaise, it'll probably react with that as well. And it creates a new thing, silver sulfide.
Mm-hmm.
Silver sulfide is made up of 2 silver atoms that have lost their electrons
Mm-hmm.
and 1 sulfur atom that's gained both of those electrons.
Okay.
So then you have a negatively charged sulfur, and it's attracted to these 2 positively charged silvers.
Got it.
So then all of those atoms are happy. They have enough electrons to fill their empty shells up. They're all satisfied, and they're hanging out with each other, so they're in a neutral state. They've got an ionic bond going on.
Mm-hmm. Mm-hmm.
And that new thing, silver sulfide, is dark colored, and it hangs out on the surface of your silver.
Interesting.
Mm-hmm.
That's crazy. We have like this word for it, tarnish, which makes it sound like it's not supposed to happen, but it's pretty natural. Obviously, it doesn't look great, but like it's kind of funny because it sounds like just saying something got tarnished, you know? It just kind of seems like, oh, it got, dirty or ruined or whatever. And it's like, yeah, in this case, that is literally tarnish, but it is completely natural and definitely going to happen.
It's just like with rust. We talked about that same thing with rust.
Yeah.
Mm-hmm. It seems like rust is wrong and bad, but actually rust is natural and spontaneous. It happens automatically.
Yeah, right. Interesting.
So that's silver sulfide. Do you want to take a stab at explaining that back to me before we talk about how chemistry can help us remove it? The second part of Mysterious Listener's question.
Yes, I'd love to. So here's a question I want to ask before I try to explain it. The sulfur that ends up wanting to bond with the silver and exchange some electrons, take its electrons, what's the reason that it wants those? Is it because it has a certain amount of electrons it wants, like kind of like other things we've talked about?
Yeah, usually that's it. So sulfur has 6 electrons in its outermost level where electrons hang out, and it wants 8. So it will steal 2 electrons from anywhere it can. And oftentimes it will, everything's in equilibrium. So electrons are always moving. We've talked about that a lot. So I think it just so happens that maybe that sulfur is already negatively charged, and if it's in the form of hydrogen sulfide gas, it's stolen an electron from these 2 protons. But maybe then it sees the silver, sees, so atoms can't really see, but it comes into contact with the silver and decides instead to steal those electrons, and then the hydrogen is free to bond with each other and make H2 gas or whatever. And so it just happens that if it comes in contact with that, the electrons might shift from there to there, and then hydrogen gas is formed, and then the silver can't go back and be with the hydrogen gas, so that's it, because the hydrogen gas is gone. Or maybe it's already in the mayonnaise or the eggs or whatever in some kind of sulfur compound that is less stable than silver and sulfur, silver sulfide. So it's probably always looking for something that will be more stable, but it wants 2 electrons that it can keep because of that outermost level wants to have 8 electrons in it. And that's kind of a complicated discussion about why it wants 8 electrons, but it just seems to be the most stable with 8.
Okay.
And then silver, on the other side of that, its outermost level can have 10, but it has 1 electron beyond that. And so it's willing to give up that electron so its outermost level can be full at 10 and not have any extras hanging out. So that's why it likes to interact with silver. That's a little bit confusing maybe if you haven't taken a chemistry class before, but it's really all about the stability of a full outer level of electrons.
Okay, got it. So here's kind of the analogy I have in mind that can work, I guess, for a lot of things, but it's what came to mind for this.
Okay, I'm ready.
Okay, so for whatever reason, sulfur doesn't always have the best gauge of friends. doesn't always have the best, doesn't always run with their best crowd, I guess you could say.
Mm-hmm.
But the good thing is that sulfur knows this about itself. So it's kind of always looking for some better friends, a little more stable friend group.
Mm-hmm. Yep.
And when it sees silver, it knows. It's almost like a really, let's say, like a really respectable, stable community member, like that. And it's like, oh, that would actually be really good and make my friend group really stable. I've never seen the show Entourage, and I've never been cool enough to have an entourage, but maybe it's kind of like that. It's like, if you've got some instability in your entourage, that's not cool. That's not good.
Right. You need a stable entourage.
Yeah. Yep. And so it goes over to the silver and is like, hey, two of you electrons, let's make this entourage stable. Let's do this thing. And it actually works pretty well because while the sulfur wants that, it's also kind of beneficial for the silver because it kind of wants to have that 10 electron outer ring going on.
Right.
And so it's like, yeah, let's do it. It's great. And they have a little stable entourage that we call tarnish.
That's exactly right.
And everybody's happy, which is funny. Just like the rust thing. Happy is kind of in quotes, but it's a thing that is stable. And
it is stable.
Both sides are cool with it.
Okay. So let me take this a step further.
Okay.
If that sulfur sees some aluminum, that's an even more stable member of the entourage.
Oh, wow.
So we can use chemistry to reverse tarnish by exposing sulfur to aluminum and giving sulfur the opportunity to make an even more stable entourage.
Nice.
So
we're kind of baiting it a little bit.
Mm-hmm, we're saying, hey, actually, it's even better than silver. We're manipulating that friend group to get what we want, which is a shiny piece of silver metal all to ourselves.
Uh-huh.
So if you take a glass baking dish or something like that and you line it with aluminum foil, and I have not done this, but I hope to have done this by the time this airs because I really want to see it. Uh-huh. Lots of people have done it. I just haven't yet.
Uh-huh.
So you can line a baking dish with aluminum and pour really hot water in there. And then put a little bit of salt and baking soda. And those things act as a sort of highway for the electrons.
Okay.
And then you can put your silver in. I think it should probably be as close to contact with the aluminum as possible.
Okay.
And you should be able to see the tarnish leaving.
Whoa. Dang, that's cool.
Mm-hmm. Yep. So you should be able to reduce the tarnish. The other way is people use silver polish, and that uses abrasion to scrape off the tarnish essentially, but that means that you're losing that silver that has reacted with the air, and it also won't get into as many nooks and crannies. So I think the gold standard is to chemically reverse your oxidation reaction by giving the sulfur option to react with something that's even more stable.
Nice. And then you're not losing any silver atoms by scraping off. So you are still doing something. You're kind of cleaning it at the molecular level.
Yes.
Nice. Dude, that's crazy, actually.
I know. So now, mystery listener, you can buy whatever piece of silver jewelry you want. Maybe buy a super tarnished one that doesn't matter to practice.
Yeah, that's it. Yeah.
And you can chemically remove the tarnish from the jewelry piece, the antique jewelry for your girlfriend for this holiday season.
Dude, that is so cool. I don't think I have any silver. I want to try this. But
I have a lot of silver, so maybe I can drop some off with you and you can test it out.
Dude, heck yeah, that'd be awesome. But that sounds so cool. It also seems like so ideal to just figure out ways to chemically reverse things. Let atoms do what they want. Like finding a way for things to do what they want, like always putting different atoms in scenarios where they'll make a choice that they'll want to make. That's a better stable bond for them. And that just seems like so much better,
It's almost like if you have kids and instead of just telling your kids, no, you can't do that, you're giving them a better option. Like you could be a hooligan or you could take part in learning how to play guitar because you've always wanted to do that,
Yeah. And especially something they'll do every time. Like if you can know they'll always rather do this than that. It's like perfect.
Oh, I forgot to say too that there can be sulfur in the air from the decomposition of dead plants and animals. So maybe have some flowers in your house and they're dying. Or I thought of, if spinach is going bad, it has a very sulfury smell. So I can only assume that there's sulfur in that, so that can also be putting some sulfur in the air in your home.
Basically, it's kind of unavoidable, sounds like, to have sulfur around.
Yeah, sulfur is maybe not ubiquitous, but is very, very present.
Mm-hmm. Dang, interesting. Dude, crazy. This was a crazy episode. This is a lot of things I did not expect.
I know. I was really excited when I found it. It was really easy to get information on this. There was lots of good resources on it. And it was just really fun. I knew sort of about silver tarnish, but I didn't know everything. So I got to learn a lot too. And it was a great episode. So thanks to our mystery listener. I mean, not a mystery to me, but
yeah.
for writing in. This was really fun. And I had a great time writing it. So thanks for giving me this opportunity.
And we'll try to give you a shout out in a later Q&R or something like that after the holidays so that you had time to do this, hopefully get your girlfriend this awesome gift and get it untarnished and stuff, and then it not ruin the surprise.
Right. 100%. So that was a really fun episode, but now I'm wondering if you have anything fun to tell us about your week, Jam.
Yes, I'm here live, reporting from my life to tell you guys about the current ongoings. As you can see behind me, there's a lot of commotion.
There's not. He's in a quiet room by himself.
Dang. Okay, so the thing that has been going on, or something cool this week, is some of our friends got married this past week.
Yes, yay.
At the time of airing, it'll have been a couple weeks, but it doesn't matter. Still was really cool. They had a wedding where only a few people were there and a lot of us watched it to be safe. Mm-hmm. We're in an area of the world and country that's got lots of COVID cases right now. And
yes, a lot.
So I was thankful they took that measure. But then we had the chance to, later that evening, which I thought was so cool and just loved that they did this. Later that evening, we got to have an outside little, I guess you call it sort of mingle or something, just to celebrate that they are married and they stayed in their wedding clothes. And so this is like, a few hours later, and we got to all see them, hang out, say hey, just kind of sit around outside and get to celebrate them, which was just really, really cool. So Sam and Andrea, we celebrate you, and we're so glad y'all are married. And that was a huge highlight of my week.
That was really actually a highlight of my week too. It was really fun. So I'm just going to steal yours.
Do it.
It was really fun. And I thought it was really smart of them to not have very many people there, because it was just, it's always a hard decision. You don't want to disappoint people, but you really want to stay safe. And so I was thankful that they took that stress off of us, but that they had a safe social distance outside, and it was bring your own food. And I tried a new Italian place that everybody loves for the first time, and the ravioli was incredible.
Oh, nice. I meant to ask you about that.
It was really good. My boyfriend got something that wasn't great, but the ravioli was really good. And actually it was big enough that we could share it, so it was fine. And everyone told us that we ordered the wrong thing. Next time we need to try something else. So I'm excited to go back. And then we all got some ice cream after at the ice cream shop there on the square. It was just really fun. It was a fun night. It was fun to see them in their wedding clothes. It was fun to see people. It felt a little bit normal. The weather was great. Yeah. Everything was just right. And it was so exciting to get to celebrate with them in a safe environment.
Yeah, for sure. Definitely a highlight. So you're not stealing it because it's not even mine. It's really theirs.
That's true. It's there. So congratulations, Sam and Andrea. We love you guys. And we're so excited for you. And thanks for throwing a fun party.
Yes.
A fun, safe, social distance outside party.
Yes. Thanks, guys.
And thanks, Jam, for learning about silver. And thanks to our listener for writing in, because this was a really fun episode.
Dude, absolutely. Some of the best topics, including this one, come from you guys. So if there's things you wonder about that you're like, man, is this chemistry? One, it probably is.
100%.
Most likely. Two, we'd love to hear about it. So please let us know. Email us at Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to S. Navarro and M. Quapple, who reviewed this episode.